Hello students, welcome to this video lesson on prime factorization using factor trees. I'm going to read this introduction at the top. You can use your divisibility rules when completing factor trees. Every composite number can be broken down into smaller factors. In a factor tree, we try to break down a composite number into factors that are prime numbers. This is called prime factorization. So let's have a look at problem 1. Complete the factor tree for the number 60. So we have 4 different possible solutions here. So step 1, list all the factors for 60. All right, so let's start doing that. So let's use our divisibility rules. We're going to rule out the numbers 1 and 60 because they're not really going to help us in the factor tree. So the first number that goes into or divides into 60 is 2. And its pair is, we know that 2 goes into 60 30 times. So let's always write our factors as pairs. All right, next. The next number that divides into 60 evenly is 3. And 3 goes into 60 20 times. The next pair is, we know that 60 is divisible by 4. And 60 is divided by 4 15 times. Next, because 60 ends in a 0, we know that it's divisible by 5, and it goes into 60 12 times. And the last number that goes into 60, the last pair, is 6 and 10. So we have 5 factor pairs for the number 60. So I'm going to scroll down a bit. Okay, let's have a look at solution 1. All right, so at the top of the tree, we have our number 60. We see in solution 1 that 60 can be divided into 2 numbers. There are 2 branches here, so we're looking for 2 numbers. So I'm going to randomly choose this pair here, 6 and 10. All right, so 60 can be broken down into the factors 6 and 10. Now you see how I wrote the numbers in ascending order? I wrote the smaller number on the left side and the larger number on the right side, but they can be flip-flopped as well. All right, 6 can be broken down even further into prime numbers 2 and 3. And if we look at this branch, the number 10 can be broken down into the prime numbers 2 and 5. So there we have our tree is ended because we have all prime numbers at the bottom. So we have a therefore statement. So we're going to write these 4 prime numbers in ascending order. So the first number is 2 right here, times 2, that's the next biggest factor, times 3 right here, times 5 equals 60. So this is called the prime factorization statement. We have 1, 2, 3, 4 prime numbers when multiplied together equals 60. So there's our solution for this factor pair here. Okay, let's go on to solution 2. So I'm going to pick another factor pair, and how about I choose 4 and 15. All right, so 60 can be broken down into the 2 numbers 4 and 15. If we look at this branch, 4 can be divided or broken down into 2 prime numbers, 2 and 2, and 15 can be broken into 2 prime numbers, 3 and 5. 3 times 5 equals 15. Now again, the 15 could have been written in this box and the 4 could be written in this box. I just prefer to keep things very organized. I put the lower number on the left and the larger number on the right. So our therefore statement, let's rewrite all of our prime numbers at the bottom of our tree. So we have 2 and we have to write them in ascending order. 2 times 2 times 3 times 5 equals 60. Now it just so happens that in this solution all of the prime numbers were already in ascending order. So this is very important, this box here. Notice how the numbers in the squares are composite numbers, while the numbers in the circles are prime numbers. So here's what I mean. So whenever we see a square, such as right here, it has to be a composite number. Whereas wherever we see a circle, it has to be a prime number. Okay, so we're going to use that information in solutions 3 and 4. Now you see, in solution 3, the tree looks completely different. We have one branch ending in a circle, which means this tree requires us to think of a factor pair where we have a prime number in this circle here. And in the square, we have to come up with a pair that where one of the numbers is a composite number. So let's look at our factors up here. So how about we choose this pair, 3 and 20. And this is going to work because I know that the number 3 is prime, and I know that the number 20 is a composite number, which is perfect. So 60 can be broken down into a prime number here, which is 3, and its pair, which is a composite number, which is 20. Now, 20 can be broken down into a composite number. Remember, squares are composite numbers, and circles are prime numbers. So how about I choose 4 and 5. 4 times 5 equals 20. Now I can break down the 4 into two prime numbers, 2 times 2. All right, so I've got 1, 2, 3, 4 prime numbers ending my tree. So when I write our prime factorization statement, I have to include all of the prime numbers. 2 times 2 times 3 times 5 equals 60. Okay? Remember to write them in ascending or increasing order. So let's look at our last possible solution. Solution 4, very similar. We have one branch ending in a prime number and one branch here requiring a composite number. So let's use this pair right here. This pair has one number that's a prime number and one number that's a composite number. So the prime number has to go in this circle here, 2, and its pair is 30. 30 is a composite number. It goes in the square. Now 30 can be broken down into a variety of factors, but I need one that is a prime number and one that is a composite number. So how about I choose 6 and 5? The 5 has to go in the circle. Even though it's bigger, that's okay. 5 is the prime number, 6 is the composite number. And now 6 can be divided into two numbers, 2 and 3, which are both prime. Now remember, we have 4 prime numbers ending our tree, so we have to include all of those prime numbers. So we have 2 times 2 times 3 times 5 equals 60. And I'm hoping you're noticing that all of these prime factorization statements are all identical, and they should be because they all reflect the answers to the number 60. Okay, so let's start problem 2 on the next page. I'll just get you started. Okay, so problem 2. Complete the factor tree for the number 75. For the number 75. Okay. So let's do like we did with problem 1. So let's brainstorm and think about all of the factor pairs that go into 75. Okay, well there aren't that many. So 75, if you think about money, 75 cents, 75 is divisible by 3. So 3 goes into 75 25 times. So that's one factor pair. And because 75 ends with the number 5, we know that it is divisible by 5 using our divisibility rules. So if we use a calculator, 75 divided by 5 is 15. And even though 75 is a fairly large number, these are the only factor pairs that go into 75. Okay, so let's start with solution 1. All right, so solution 1 requires us to use a pair where one of the numbers is a prime number and one of the numbers is a composite number. So let me just scroll a little bit more up so I can see. Okay, that's fine. All right, so we have really only two possibilities, don't we? So one of the numbers has to be prime, so let's use this example right here. All right, so I want you to complete the factor tree for solution 1 and solution 2, and then once that's done, you can progress on to problem 3. Thanks for watching. Bye.